Hello, everyone. Welcome. I am Jet Aguilar from the Astronomical League of the Philippines, and I will be hosting today's webinar. Thank you for joining us for our 2023 Astronomy Expert Speaker Series. Today is also Global Astronomy Month, this month. So we are very fortunate to have today with us Dr. Daniel Green, the director of the IAU Central Bureau of Astronomical Telegrams, who will give us a brief tutorial on comets. Dr. Green will discuss what comets are, how they are becoming harder to define in terms of their physical nature, how they are discovered and named, and also some statistics regarding comets and how amateur astronomers can contribute greatly to the science of comets. My fellow ALP member, Ms. Imelda Johnson, will be doing introductions for our esteemed speaker later, and we also have a surprise guest with us. So for those who are not able to register but would still want to watch this ongoing webinar, we are currently live streaming on Facebook at the Facebook page of the Philippine Astronomy Forum. Before we start, kindly allow me to explain some rules for this webinar to help us make this an enjoyable learning experience for everyone. Please listen and do your best to give your undivided attention to our speaker. There will be a short question and answer session at the end of the lecture. You may type in your questions under the Q&A tab found in your Zoom interface at any point during the presentation. We will do our best to read and answer your questions live after the lecture or via the Q&A tab. We would like to remind everyone that the contents presented in this webinar will remain as the individual property of the lecturer and the photographers in the presentation. And we will also be distributing certificates of attendance via email to all registered attendees who will be present with us throughout the webinar. So please use the name you have written in your registration forms to help us facilitate this process. So enjoy the webinar and let us all have fun learning. Here's the program flow for today's webinar. And now I would like to turn you over to Mr. James Caventy, the President of the Astronomical League of the Philippines, to give his welcome remarks.
Good morning to all our viewers in the Philippines, and good evening to our guests in the United States and Europe. My name is James Caventy, President of the Astronomical League of the Philippines, and on behalf of the ALP, I would like to welcome you to our Astronomy Experts Speaker Series 2023. This webinar is part of the ALP's International Astronomy Educational Outreach Program. Our goal is to bring renowned experts and scientists to the Filipino people and to the rest of the world. This is why the webinar is being offered free to the general public. I'd like to also take this opportunity to thank ALP members who has been instrumental in putting this program all together, especially Imelda Johnson, Edwin Aguirre, Dr. Jet Aguilar, Jun Lau, Henrik Colty, Andrew Ainchan, and Peter Benedict Tobalino. So this will be the 12th lecture in our speaker series. So our speaker for today is no other than Dr. Daniel Green, the Director of the Central Bureau of Astronomical Telegrams. We have more distinguished speakers lined up for the coming months, and so please stay tuned, and please do not forget to register in advance for these future webinars. Thank you very much, and I'd like to turn over the program to Imelda Johnson, who will introduce our guest speaker for today.
Thank you very much, James, and good evening to all our viewers in the United States, and good morning to all our viewers in the Philippines and in the Southeast Asia region. Since we are talking about comets, before introducing our main speaker for tonight, we have a very special guest, a comet discoverer extraordinaire, our dear cousin David Levy, who will read to us a brief poem.
Thank you so much. The more I watch the introduction to the Astronomical League of the Philippines, this is the third time I've seen it now, the more meaningful it gets to me. It is wonderful. I'm really enjoying that. Tonight's poem will be in 3 parts. First, I will read it in a different language, then I have a little story, and finally I will read it to you in English. Mi stars kaj gapis, la cielo estis lumigita, la cielo estis steloj CANG. Mi staras, mi ne scias kial, sen desiro, sen volo, mi staras sur tiu silentia monteto, kaj rigardas on la cielon gis, miaj okuloj estis blindaj pro steloj kaj senmovaj, mi rigardis on la cielon. Do any of you know what language that is? Nobody's jumping up and down. One of you does, because I told one of you, but anyway, the language is Esperanto. It is a constructed language constructed by Dr. Zamenhof, who was an eye doctor living in Poland. And Esperanto is Esperanto for hope, because he hoped that through a common language, the nations of the world would be able to get peace. We're still hoping, but we'll see. I'm now going to read the poem in English, written by Ralph Hodgson around 1917. And I'm reading it because it was my late wife's Wendy's favorite poem, and she often, after I would be giving a talk or a lecture or something, she would join me at the microphone to quote this poem together. We can't hear her anymore, but I like to think that from where she is, she can hear me dedicating this to her. I stood and stared. The sky was lit. The sky was stars all over it. I stood. I knew not why. Without a wish, without a will, I stood upon that silent hill and stared into the sky until my eyes were blind with stars, and still I stared into the sky. Thank you very much.
Thank you very much for that very inspiring poem, Cousin David. We really appreciate you sharing it with us and with our viewers tonight.
Thank you.
So, yeah. So it is a great honor and privilege for me to introduce today's speaker. He is not just a next town neighbor to both Edwin and myself, but also a fellow eclipse chaser and our new observing buddy. We've been longtime friends since 1995 and share a common brother in Steve O'Meara. Dan Green needs no further introduction to cometary astronomers, comet hunters, and comet enthusiasts. Dan Green is the director of the Central Bureau for Astronomical Programs based at Harvard University in Cambridge, Massachusetts. He obtained his Ph.D. in physics and astronomy from the University of Durham in the United Kingdom. He has devoted much of his career in research in the analysis, archiving, and publication of data from around the world on comets, meteors, and minor planets. He is the editor of the world's largest and leading journal on comets, the International Comet Quarterly. Dan is also very much involved in observations. He directs the nightly acquisition of CCD images of comets using telescopes in Tibet, searching for new comets and near-Earth asteroids. He's a member of the International Astronomical Union's 16-member committee on small body nomenclature, which approves names for comets and minor planets, including trans-Neptunian objects and their satellites. He's a member of Harvard's Origins program, with an interest in how observational data of comets can help in the study of their origins and in the origin of the solar system itself. Friends, let us give a warm welcome to Dr. Daniel Green.
Thank you. Let's see, share my screen here. Okay. Great. So, greetings. It's a pleasure to be here. I presume everyone can hear me okay? Okay. So, I'm going to start out with a little history. Comets have fascinated people throughout history. In the distant past, people were very confused about what comets were. They could be scary because they would come out of nowhere. They were not predictable. And many people associated them with significant happenings in history and in people's lives. So they were part of astrology. And they also ended up, in a scientific way, being huge catalysts in the historical development of astronomy. So all along the way, over the centuries and even the millennia, comets have been a big part in the development of astronomy. So the ancient Greeks had different ideas about what a comet might be. Pythagoreans considered them to be one of the planets. And indeed, this was actually pretty close to reality because they really are small planets that go around the sun. Although they are in different types of orbits than the major planets are. Even so, in more modern times, after the telescope had been invented, William Herschel found the first new planet that had not been known previously via naked eye, and that was the planet Uranus. And prior to this, it was very unusual for a new object to be found in the sky. All you had were basically comets and exploding stars, novae or supernovae. So William Herschel was very confused about this. And he at first thought that it was a planet. So then in the early 1800s, we had minor planets that were found as well. Ceres, Pallas, Juno, and Vesta. So that added to the list of new objects. And astronomers came to realize that there are a lot of other things out there besides just comets and the planets. But Aristotle had placed comets with meteors in the atmosphere. He was misguided, but that theory about comets went all the way down through the Middle Ages. Many people subscribed to that, even though some of the ancient Greeks had called them planets or planet-like objects and something beyond the atmosphere. But without telescopes, it was really hard to figure out what was going on. So the comet of 1577 is a comet that I've studied a lot. It formed a big part of my PhD thesis. And the comet of 1577 was one of the brightest comets of the last 1,000 years. And it occurred shortly after the invention of printing in Europe. And so there was a huge explosion of writings about this comet because it was a very, very bright naked eye comet. And of course, there wasn't much light pollution back then. So if you had a clear sky, you were going to see this comet. And this ended up being the comet that destroyed Aristotle's theory of comets being in the atmosphere. And Tycho Brahe really kind of proved that it was well beyond the orbit or the atmosphere of the Earth, and in fact, beyond the orbit of the moon. So this comet was also interesting because we saw some of the earliest diagrams in print of comets, not the very first ones, but among the very first ones. And what was interesting, you can see here, in this diagram is that there are two tails. And this was very interesting. Here you can see the motion of the comet across the sky. In one of the books that was published on the comet of 1577. And you can see how the tail grew longer and longer as the comet came closer to the Earth and to the sun. This was an illustration from Cornelius Gemma of the comet of 1577. And what's really interesting here is that you have a curved tail and a straight tail. And that represents, the curved tail is the dust tail, which appears to us as yellowish or whitish, whereas the ion tail, the straight tail, is not dust, it's ionized gases, and it tends to be more bluish. And this is the first really strong case of people seeing both the ion tail and the dust tail, which is very interesting. And you see it in diagrams from different authors, different observers here. The ion tail is normally not that bright. Normally, when you see a bright comet tail, you're seeing the dust tail. So in the case of the ion tail, for the ion tail to be easily visible to the naked eye, the comet had to be pretty bright. So prior to printing, basically people communicated by word of mouth and handwritten manuscripts, of which there were only a few copies. So the first printed books on comets didn't happen in Europe until the 1472 comet. Then Halley's Comet came in 1531, and as more and more comets became visible, many, many more books were published, and the development of scientific and astronomical journals started occurring in the late 1600s. In the 1860s, telegrams started to be used for announcing comets. And I've been at Harvard my entire career with the Smithsonian Observatory for the first 30 years, and for the last 13 years, I've been at Harvard University itself. But Harvard has a big history with comets. And there was a bright sun-grazing comet in 1843 that caused the local people to get money together to build an observatory here. And that building is still standing. It's one of the oldest observatories standing in the United States. It was built in 1846, 1847. Donati's comet then came the following decade. That was also a big issue. And so comets were important here from the beginning, even though Harvard is well known for its stellar astronomy and other pursuits in astronomy. But the comets continued to be a big problem. And there was a bright sun-grazing comet in 1882, and it was very difficult to get this information around. There was no coordinated way in order to get reports of new comet discoveries sent quickly around the world, because comets would often not be observable for very long. So the telegram had been coming in, and they laid underwater cables between Washington, D.C. and London. And so it was arranged that telegrams would be sent regarding new comets to Washington, to the Smithsonian Institution. And in 1883, the Harvard Observatory set up a bureau to handle dissemination of information in the Western Hemisphere. So Harvard Observatory they would put out these bulletins in which you can see here, William Brooks discovered one of his many comets. This is dated 1904. And what they would do is handwrite a bulletin from the telegram, and they would send it out to subscribers. So what also happened in Europe at the same time is that a Central Bureau for Astronomical Telegrams was created in Kiel, Germany. And the reason why it was in Kiel, Germany is because that was where the Astronomische Nachrichten was published, which at that time was the premier astronomical journal in the entire world. And so they started a central bureau as a clearinghouse for new discoveries. And that continued at Kiel until World War I. And World War I, because of the disruption of the war, the Central Bureau moved to Copenhagen, Denmark, where things were more stable than in Germany for obvious reasons. And eventually, the Central Bureau moved to Cambridge in 1965 from Copenhagen. This is an illustration of a photo of an actual IAU circular. This was number 60 from 1925. So we continued printing these circulars. The printed circulars were done from the 19-teens under the Central Bureau all the way up until 2015. 2015 was when we last printed an IAU circular. Now everything is electronic. But as you can see, there are comets announced here on this particular circular. It was mentioned in your introduction here about the comet that hit Jupiter, which David Levy was involved with discovering, which is formerly known as D 1993 F2, Shoemaker-Levy now. And it broke into many pieces before hitting Jupiter in spectacular fashion in 1994. And this was right at the time that the World Wide Web started up. So there was a big transition at this point to getting things on the World Wide Web in a rapid manner. In fact, my first big memory of the World Wide Web was seeing photos of this comet hitting Jupiter, which is very interesting. Hubble Space Telescope images and other telescopic images were thrown up on the World Wide Web in its infancy at that point. A few years before that, the previous decade, we had a comet known as IRAS-Araki-Alcock, which was discovered by the IRAS satellite and then two amateur astronomers visually, Araki in Japan and Alcock in England. And this comet really pushed us to the edge because there was no way to get information out to the general public at this point other than through our printed circulars, which would take a week to deliver by mail to print and deliver them, or by telegram, which most people didn't have access to, or telephone. And so we had a lot of problems with this, and this caused us to start an online computer service back in the early days where people would dial in through their telephone to our computer and actually get information. And this was in place when the supernova 1987A exploded in the Large Magellanic Cloud, which was also a big deal. And that was one of the last really big reports of an astronomical discovery that came by telegram. So what are comets actually? So we've looked a little bit at the history of them. Well, we've had some close-up looks at comets. It used to be that everything was distant imaging through spectroscopy or direct photography. That's all that we knew about comets. Of course, we knew about their orbits. We knew from watching their observations over days and weeks and months, we could calculate the orbit, and we got a lot of statistics on that. But we didn't really know what the surface of a comet looks like because what distinguishes a comet from a minor planet or an asteroid is that it has a coma, which is basically an atmosphere that is very close to the nucleus as it nears the sun. And almost all comets have a coma. Occasionally you have a comet that just appears to show a tail. That's kind of a different category, and no coma. But basically, it is thought that very rarely do we ever see the true nucleus of a comet from Earth because there's always some coma, which is basically a mixture of gas and dust. The gas sublimates off of the nucleus due to sunlight, and it carries dust and small rocks and things off of the nucleus to form this coma or atmosphere. Well, we've had a few spacecraft that have actually brought back good imaging of comet nuclei. So we have several comets that have been seen now. You can see here, Halley's Comet was the first in '86, but then it was another decade and a half before we got the good view of our second comet. This is what Halley's Comet looked like from the Giotto spacecraft. And you can see here the jets that are going out from the nucleus. We can't see the nucleus from Earth because there's too much debris, gas and dust surrounding the nucleus for us to be able to see that. And the nucleus is very dark, has a very low albedo, so it doesn't reflect a lot of light. But you can see here that there are active areas on the nucleus and there are inactive areas on the nucleus. So most of a comet's surface is thought to not be that active. So you mainly have certain areas on a comet nucleus that are active and others are not. And the comet's nucleus is also rotating. So that presents some interesting complications as well. This is 19P Borrelli. Here's the comet 9P Temple was impacted by the Deep Impact spacecraft, NASA spacecraft. And we got some interesting images. There was a secondary camera on another spacecraft that took pictures of the main object impacting the comet. And you can see this is 9P Temple. And there's not a whole lot of activity going on here, interestingly. But you can see it's very rough surface. It's not at all round. It's very oblong shaped. There are craters there, which are doubtless impacts from meteoroids that are going through space and hitting comets. This is 81P Wilt. You can see it's a little more on the round side, but it's still kind of oblong shaped, and it's very pockmarked with craters. So generally speaking, we have oddly shaped nuclei that have low albedos. Halley showed a size of 15 kilometers by 7 to 10 kilometers. And the Giotto spacecraft measured about 80% water, 10% carbon monoxide, 2.5% methane and ammonia, and then trace amounts of hydrocarbons and other atoms. We saw similar things from the other spacecraft. The other comets that we visited with spacecraft are smaller. 67P Churyumov-Gerasimenko has a nucleus size of about 4 by 3 by 2 kilometers. 81P Wilt, 5.5 by 4 by 3 kilometers. 9P Temple, about 7.5 by 5 kilometers. So you can see that there's generally the comets that we've sent spacecraft to are in the similar ballpark in terms of size. So a few definitions. Difference between comets and minor planets is that we have basically some kind of activity with a comet. So you have a coma or you have a tail or both. Generally, minor planets are what we would say are asteroidal objects. They do not appear to show obvious tails or coma. Now, we are finding that certain minor planets like Ceres in the main asteroid belt actually do appear to emit have some water ice and have some sublimation at a very small level. So the whole boundary between minor planets and comets is getting fuzzier and fuzzier. And as we discover fainter and fainter comets with our surveys and our larger telescopes, it's getting more and more difficult. And a lot of times we'll have an object that's reported as a minor planet. It gets a minor planet designation, and later it's found to show a coma or a tail, and it gets converted to a comet. Some of the other terms we have, perihelion is used as an important way for comets because comets are in very elongated orbits. And so, for example, Halley's comet comes well inside the Earth's orbit at perihelion, but at aphelion, it goes way out beyond the planet of Neptune. So that's a very elongated orbit and takes about 76 years for Halley's comet to make a complete trip. On the other hand, Encke's comet, which was the second comet found to be to return, and so it's called 2P Encke. So we use this numbering system for comets, short period comets that have been observed two or more times. And Encke's comet is at the opposite end of the spectrum. It's only has an orbital period between 3 and 4 years. In comets, we use the term apparition, which is a historical term. It goes way, way back, thousands of years, but we still use that as a term to refer to their visibility. So Halley's comet had its last apparition at its last perihelion in 1986, as opposed to a regular planet which we refer to having, say, an opposition, right? Which is where it's opposite the sun in the sky, but their orbits tend to be much more circular in nature. So how bright do comets get? Well, they can get pretty bright. And of course, we all are excited at the prospect of finding a really bright comet. Well, over the last century, there have been some very bright comets. Nothing has really approached Comet Ikeya-Seki in 1965, which was approaching the full moon in brightness. An extremely bright comet. That was a sun-grazing comet, went very close to the sun and had a very long tail. A lot of people are amazed to see that by far and away the second brightest comet of the last century was McNaught's comet in January of 2007. The designation was 2006 P1 because McNaught found it some months earlier in 2006. Comet West is well known to a lot of astronomers, got up to about magnitude -3. You can see the fifth place one is an eclipse comet, the 1948-6, which, I'm sorry, V1, not 6, got up to about magnitude -1, and it was seen during a total eclipse of the sun. Comet Hale-Bopp, which is one of the more famous comets of the last couple of decades, got down up to about magnitude -0.8. Hyakutake, 1996, reached magnitude 0. Hyakutake and Hale-Bopp are very interesting contrasts in comets because Comet Hale-Bopp was intrinsically a very bright and very large comet in terms of the nucleus and activity. Hyakutake was a little teeny comet. And you can see here, though, they almost approach the same brightness. Well, you can guess right away the reason for the difference is that Hyakutake, the little teeny rinky-dink comet, came really close to the Earth and was observable, had a tail that stretched on the order of halfway across the sky overhead for Northern Hemisphere observers. It was a spectacular comet if you were in a dark sky in 1986 when it was closest to the Earth. When the problem with Hale-Bopp, even though it was intrinsically a very bright, one of the brightest and largest comets that we've ever seen, was on the far side of the sun at perihelion. But it was still, Comet Hale-Bopp has the record for the longest naked eye visibility. I believe it's on the order of 1.5 to 2 years that it was naked eye visible. We're not likely to see another comet like that for a very long time. And in fact, in recorded history, we don't know of any comet that approaches that level of visibility. Now, if Hale-Bopp had been on our side of the sun at the time of perihelion, it would have been absolutely spectacular. Would have been a daylight comet. It would have cast shadows at night. It would have been absolutely spectacular. But alas, it wasn't. So I'm going to show you some pictures of McNaught's comet, 2006 P1. Simply because it's the second brightest comet of the last century. You can see in this photo, if you look closely at the upper left part of the picture, in the purplish part of the sky, you can see the comet with a tail. Now, this is broad daylight. That's the sun. That's not the moon. That's the sun. This comet was visible to the naked eye in broad daylight in the second week of January 2007. And interestingly, this was not reported on by the press at all. Northern Hemisphere observers missed out on it because this comet with a high inclination went south after perihelion and was visible just in the Southern Hemisphere. But this is a photograph by Rob McNaught, the discoverer of the comet. He took this from New South Wales in Australia. When the comet was near its peak brightness, and you can see the fabulous tail as the comet rounded the sun, the tail lagged. That's why you see it curved, and you see these striations in the dust tail. Well, notice those striations in the dust tail, because, and this is a photograph from the Seki satellite of the detail in the tail of McNaught's comet. But take a look at this photograph. This is a Northern Hemisphere photograph from Italy where the head of the comet was not visible at all. It was Southern Hemisphere comet, but we're looking at the tail here in this picture, right? So if you can see the striations here, it looks a little bit like Aurora Borealis, right? Or Australis. But that's actually the tail of the comet coming up above the horizon. The tail was so long and so huge. And here's another observation of the tail from southern France. Steve O'Meara took this photograph from Hawaii, from Mauna Kea, with the bright moonlight. So you can see how bright the tail was, that it's not drowned out by the moonlight. Here's another very interesting picture from Haleakala, Hawaii. You can see the tail in the sky here, and it's very interesting because you have a meteor in the picture up near the top center, and then the moon below. And here's a photo of McNaughton's Comet over Perth in Western Australia. Another picture from Western Australia, January of 2007. That's the moon again on the right. And here you can see it shining through clouds. Just a very impressive comet. I wish we could get another one like this in the Northern Hemisphere soon. I don't know if anybody in the Philippines saw that. We can talk about that later if you saw this comet. You might have been far enough south to see some of this. This is from Christchurch, New Zealand, a wide angle photograph showing the Milky Way, large and small Magellanic Clouds, and McNaughton's Comet down at the bottom there. And then as it pulled away from the sun, Gordon Garrod took this photo from Siding Spring in Australia. You can see the comet near the bottom, just above the cloud bank, with the large and small Magellanic Clouds up above. So here's a diagram from the Minor Planet Center showing the inner solar system. So the circular ring on the outside here is the orbit of the planet Jupiter. And inside that, you have all these green, the green donut, which it appears is actually each one, it's a collection of tens of thousands of green dots representing minor planets in the main asteroid belt between Mars and Jupiter. Then you have the red objects are actually Earth crossers. And so these are minor planets that cross the orbit of the Earth, mostly inside the orbit of Mars, but not entirely. The blue objects in here are all comets. And you can see comets go way out beyond the orbit of Jupiter. They're scattered throughout the solar system. And this is a view looking down from above of the solar system. Now we're looking at the outer solar system. So the outermost circle here is Neptune. Then you have Uranus, Saturn, and Jupiter as the innermost circular orbit. They're not quite circular, but they're just slightly elliptical. But again, the blue symbols are all comets. The red and pink symbols out in the outer portion are actually trans-Neptunian objects. So comets tend to be in highly elliptical and chaotic orbits, meaning that they cross the orbits of the major planets and so can be heavily perturbed by them, meaning their orbits change a lot. As opposed to, say, asteroids in the main asteroid belt, they are not really perturbed very much. They stay in their orbits for a very long time. Comets crossing, comet orbits that cross the orbit of the Earth actually can show up as meteor showers because as the comets are spitting off material, dust and gas going as they go around the sun, they leave debris behind, and we see them as meteor showers. And then if you go even bigger, way to the outer part of the solar system, we found through statistics of collecting hundreds and hundreds of comet orbits that many comets seem to come from what we call the Oort cloud, which is a region that is tens of thousands of astronomical units away from the center of the solar system. So we don't entirely know exactly why the Oort cloud exists as it does. That's one of the mysteries that we have. But one thing that we do know is that comets are ejected from the solar system completely in many cases due to perturbations by the planets, and most of them are close approaches to Jupiter. Jupiter is very strong at ejecting comets. So we've done a lot of cataloging of comets over the years. And cataloging comets means that you need to have some kind of standardization. And it took time to get this kind of standardization together. There are a lot of comet catalogs that were put together centuries ago, and they got increasingly better and better as astronomers learned more and more about comets. And of course, Edmund Halley is known for doing some of the first cometary orbits, working closely with Isaac Newton with his new mathematical physics. And he noted that 3 orbits of 3 comets, 1531, 1607, and 1682, were similar, predicted that it would return in 1758, and it did. And it's been known as Halley's Comet ever since. Brian Marsden did a series of catalogs of cometary orbits of all the known orbits of comets, severely out of date now since Brian died in 2010, and that's one of the projects that I'm working on to try to get updated. We have many new comets found since 2010. So we've had comet hunting became a really big thing in the 1700s. Charles Messier was one of the first big comet hunters. He found 13 of them in a period of 38 years in the late 18th century. Just a little bit of interesting information. The youngest known comet discoverer was a kid named Whittaker in 1968. He was only 16 years old. The oldest known discoverer was Albert Jones of New Zealand in 2000. He was 80 years old, and he had found a comet at age 26 in 1946. So that's kind of a really interesting story, the Albert Jones story. Albert Jones just died in the last decade, not too long ago. So over the years, there were some comet awards that were given out to encourage the competition and reward people for hunting for comets. The Danish king, Frederick VI, awarded a gold medal for a period from 1831 to 1847. And Heinrich Schumacher, who's editor of the Astronomische Nachrichten, was involved in that. That was the Astronomische Nachrichten, of course, is the original starter of the Central Bureau for Astronomical Telegrams. Another gold medal was awarded in the late 1800s by the Imperial Academy of Sciences in Austria. And then Warner gave out $200 awards for comets discovered in the 1880s. And Edward Barnard is famous in Nashville, Tennessee for having built a house from all the money he got from discovering comets for his family and himself. Then there was a Donahue Medal of the Astronomical Society of the Pacific. That was perhaps the longest lasting medal for comets. That went from 1890 to 1954. And then in the 1980s, I don't have the exact years, but Roger Tuthill had an award that he gave out. And then finally, Edgar Wilson came along and started up. When he passed away, he left in his estate $1 million for giving out awards for comet discoveries in forever, basically. However, that has apparently stopped in 2015, and I'm trying to figure out what's going on with that. But the Donahue Comet medals looked like this. This was the Astronomical Society of the Pacific. And this is the medal that was given to Fred Whipple when on the discovery of one of his comets with the Harvard cameras in 1933. This is a Tuthill Comet Award that went to Michael Rudenko in 1984 for his discovery of a comet from Massachusetts, which was a truly extremely wonderful feat because Massachusetts has horribly cloudy skies and they're horribly light polluted. And here's David Levy's, one of his awards for Comet 2006 T1. This is the Edgar Wilson Award that he got. So comets are named for their discoverers. Up to 3 is the maximum, but we try to go for only 2 names now. We changed the designation system in 1995, so Hale-Bopp was known as 1995-01, and that's because it was the first comet discovered in the second half of July 1995. So O is the half month for the second half of July, and 1 is the first comet that was found in that. So there are a lot of big automated surveys today that dominate comet discovery. Pan-STARRS is the biggest one, followed by Catalina and Mount Lemmon right now. They discover basically dozens of comets every year. Some comets like SOHO comets, which are spacecraft comets, are not named for individuals. They're just named for the spacecraft. Don Machholz passed away last August from COVID-19, sadly. This is a photo of Don showing his comet hunting binoculars to Brian Marsden back in the early 1990s. One of his comets is a periodic comet, 96P Machholz, and it comes to perihelion every few years, very close to the sun, and it's observable each time by satellites that are observing very close to the sun. So this is the SOHO spacecraft. This was just this past January 31st when it was near perihelion rounding the sun. You can see the spikes coming out from, so the sun is hid behind an occulting disk at the center, and the spikes coming out from the center are the solar corona. And then you see the comet to the upper left at about 10:30 position, just outside the brightest coronal stream there. So I'm not going to go into too much more detail on the designating. So short period comets are numbered, as I said, in order that they are found to return to perihelion. And so Halley's was the first one that gets 1P, Encke was 2P, et cetera. So we're now up to 456 numbered short period comets as of about a month ago. And so the top numbered comets to date are 61 comets for the linear program, which is run by the Air Force from New Mexico. It's no longer operational for finding comets as of now. And McNaught also stopped. McNaught in this list has 21 here. Pan-STARRS has 29 and NEAT has 22. NEAT is also defunct. So in the top 4 comets, in terms of numbered comets, the only survey that is still running is Pan-STARRS, and they're going to get a lot more because they're discovering a lot of comets. And this is a list that I put together actually about a month ago. So we've had a bunch of comets since then, but this gives you a good idea. If you look at this list here, this is the comets discovered in January, February, and March of this year. Well, actually from the 3rd week in January up until the end of March. But you can see from this, you can see an idea of the types of comets, the names, et cetera. In this list, you'll see there are about 4 Pan-STARRS comets. A couple of interesting ones here are Edwards 1971 M1. You think, why is that a newly announced comet? And then 1951 G1 Groeneveld. These are interesting because these were found by Mike Meyer and Gary Kronk, who are working on a new book on comets that were not confirmed. And they managed to find additional images of these comets, and we've now been able to compute orbits and thus give them names. So that's very interesting. There are also dual status objects. The first dual status object was Chiron, which was a Centaur object that was discovered in the outer solar system by Charlie Cole at Palomar. So it appeared asteroidal when it was first found by Charlie Cole. But as it approached perihelion, Karen Meach and Mike Belton found that it had a coma or an atmosphere. So it received dual status as a comet and a minor planet because it had already been numbered 2060 in the minor planet catalog, and it was given the number 95P in the comet catalog. So we now have a bunch of comets that are like this, which have both minor planet designations and comet designations. So this is an ongoing problem. And here's just a list of a few recent objects where objects were given minor planet designations. So the designation, in this case, 2021 QM45, was found by Pan-STARRS, but it was given that minor planet designation, QM45, and then it was found to show cometary activity later and given a comet designation. So the C/ in front of the designation means that it's a comet with an orbital period greater than 30 years. Okay, if it's under 20 years, it gets a P/ in front of it. If a comet that has a period of 50 years is observed to return, it gets a C slash at the first return, it gets a P slash at the second return, okay? And then like David's comet, you may remember that hit Jupiter, that comet now is a D slash comet. It means it's basically defunct or, you know, no longer exists. We have a bunch of those as well. Comets are known to fall apart and split up. Here we have a list from the Minor Planet Center website of the closest approaches of comets to the Earth. The closest approach was Lexell's comet in 1770. It came only 0.015 AU from the Earth. And then we know, we didn't know then, but we know now that 55P Temple-Tuttle came very close to the Earth in 1366, because we have enough observations of this short period comet that we can run it back in time and see how close it really came. It was observable it was observed in the records in 1366, but of course we didn't know then how close it came to the Earth. IRS-Araki-Alcock, which I mentioned earlier, was the fourth closest approacher. That was in 1983. And Halley's Comet in 837 is number 5 on the list. That was a spectacular apparition of Halley's Comet. So I mentioned that split comets are a very common occurrence. We've had some in the last year. They happen quite frequently, especially to short period comets, which go around the sun a lot and have a lot of stress put on, and because of the constant solar heating at every return to the sun. Comets are also known to have large outbursts in brightness, and one of the most spectacular such events happened in 2007 to comet 17P Holmes. And here you can see a development of how the comet just had this superb eruption of material. And in the upper right-hand corner is the moon to scale. So you can see that the apparent size of the comet, which was much further away than the moon, was actually quite a bit larger than the moon in size. And I have a couple more pictures of the Comet Holmes outburst in 2007 November, which was quite spectacular. Here it is in the upper left corner. And that's M31, the Andromeda Galaxy, in the upper right corner. And 17P Holmes had another big outburst in 1892. Edward Barnard, the one who built the Comet House in Nashville, Tennessee, he photographed the comet here, near the bottom of the photograph, again, near M31, the Andromeda Galaxy, which is near the upper right of the photo. It had another similar outburst. And this is again showing the comet, it's dissipating the coma after the outburst in early 2008, a couple months after the initial outburst. So it's talked a little bit here about how comets have changed the way that astronomers report observations. We now send things out through Central Bureau Electronic Telegrams, or CBATs. Designations are now announced via MPEX from the Minor Planet Center, CBATs from the Central Bureau, and also the Working Group on Small Bodies Nomenclature Bulletins that are part of the IAU. The Minor Planet Center collects, analyzes, publishes, and archives astrometry and orbital data on all natural minor bodies orbiting the sun, including satellites, including comets, including trans-Neptunian objects. There's a lot of comet stuff on the World Wide Web that you can find. There are some good sites that I have not included here, including some from amateur astronomers that are quite good, including Yoshida's website from Japan. Seiichi Yoshida does a really good website on observable comets. And the Comets mailing list is hosted by Mike Meyer. That's well known in the community. It's been around for a couple of decades now. We have the ICQ Comets Observation Forum, and it looks like this. This is on Facebook, and it's probably, if you want to see comets and really good images of comets, there's probably no better place in the world to go than the ICQ Comets Observations Facebook on Facebook. We have observations are dumped onto our page daily by really good photographers from around the world. We're working on archiving all these data, all these images, all the observations to put on our own web server so that they'll be indexed by Comet. Because Facebook is a horrible place to index anything, but it's a good place to collect things. Another thing that we started last summer was a YouTube channel, and it's called ICQ Comets and Cousins, and we have what is it, 8, 10? We've something like 10 videos up so far. We're trying to put up 1 video a month. So if you go to YouTube and type in ICQ Comets and Cousins, you'll be able to see the latest news, and we're also doing interviews. So every other month we do a news video, and then in alternate months we do an interview with some comet expert around the world. So we're having a lot of fun with this. We have a team of 6. We're working on this now, and I encourage you to have a look if you're interested in that. We do have problems and needs in the field, so we're trying to solve some of that by putting everything together in one place on one computer where people can access information by comet, where you get everything from information about the discovery to observations, both visual and photographic, astrometric, spectroscopic, et cetera, orbital information, ephemerides, images, everything. We're trying to get all that. We're working on that now. We are trying to get some funding to help work on that, but we're doing it right now without a whole lot of funding, so we'll get there. So anyway, I think I will stop there and open it up for questions.
Thank you so much, Dan. Hello. So can you hear me? Yeah.
Yes.
Yeah. Thank you so much for that great presentation. Now in that we only now appreciate not only the beauty of comets, but what we always wanted to know about comets and their science. Thank you so much. I would just like to share that my earliest memories of comets was from my grandmother in the Philippines. And when we see comets at that time, she told me it's like a broom, and it presages bad events like war or famine, because it's like a broom that sweeps away people's lives. But that was how it was viewed at that time.
I think that must be common in Asia, because I think the Chinese had that symbolism of a broom as well, the ancient Chinese. So I think that's been around for millennia.
Yeah,
long time.
Thank you. I just like to share that.
That's
for the
interesting.
younger people. Before I go to the Q&A, maybe I can ask our esteemed guest, David, if he can do a short reaction to Dr. Green's talk, and then maybe to be followed by Imelda, who wrote a book on comets, actually.
Well, thank you very much for asking. I was just going to send a letter to you, Dan, and my letter was going to say, geez, Dan, excellent, with a capital E and a capital T. I loved it. You had a lot of information that I really wasn't aware of, and the information that I was aware of clarified enormously. Thoroughly enjoyable evening. That's my reaction. Thank you.
Thank you, David.
Thank you, David. Imelda?
Well, you know, I can't say a lot more than what David said about this talk by Dan. He's really excellent at this, and we really enjoyed it, Dan. The photos were amazing. So I was asking Edwin earlier, and maybe this would be a good question for you, Dan. So, you know, Tunguska,
the object
that did that.
Yeah.
Was it a comet?
Well, it's interesting because in our most recent interview on the YouTube channel, we interviewed Dr. Zdenek Sekanina, who's retired from the Jet Propulsion Laboratory. And he thinks that it was asteroidal and not a comet. But for the last century, it's been speculated that it might have been a comet because it blew up and it didn't leave a crater. It's still very puzzling. I still hold out on that it might have been a comet, simply because comets are thought to be a lot more fragile, and there was no crater from it. You know, there was a big explosion. It exploded very high in the atmosphere, and it must have been a sizable enough object to create such a big explosion. It's just it's one of those unanswered questions.
Well, yeah, I just wanted to add that your talk on comets tonight then brought back a lot of fond memories, because comets are very close to our hearts. My own interest in amateur astronomy began with Comet West, and Imelda, without giving her age away, was born with a bright comet in the sky. Yeah, and as Jet had mentioned, our very first book was about Halley's Comet. It was published in 1985 by the National Research Council of the Philippines. So you when you were talking about Halley, it brought back a lot of happy memories regarding that period. And yeah, thank you so much for a very excellent and very informative talk.
And I feel that will not be the last book on Comet that we will write. You know, as I was mentioning to David earlier this afternoon, and to Dan, you know. So, but this is inspiring us. You know, it's going to be years down the road, but it's inspiring us, really.
Yeah. Thank you so much, Dan.
Good. Thank you, Imelda.
Another follow-up question. With all the surveys that are going on around the world, what are the chances of a comet that we don't know impacting Earth?
Oh, I think I've said for a long time that I think it's more likely that a significant impact of the Earth comes from a comet, a long period comet, than from a minor planet, right? And the reason for that is that the surveys have been going for decades now, and they're finding smaller and smaller objects that come close to the Earth in terms of minor planets or asteroidal objects. We still get blindsided by some, like Chelyabinsk was a really big deal a decade ago. That's the object that it came from the direction of the sun. We never saw it coming. It wasn't all that big. It was thought to be about the size of a bus, but it caused a lot of damage in Chelyabinsk, Russia, and about 2,000 people were injured from flying glass because glass broke in high-rise buildings all over the city because of the sonic boom caused by the meteorite that hit there. And so Chelyabinsk alone, my understanding is that it caused NASA to double the funding for searching for near-Earth objects. And so I think we're getting smaller and smaller. I don't know exactly what the estimate is in the near-Earth near-Earth object community, in terms of what they think we are down to. I suspect that we have found so far probably just about all the objects that are over about 1/4 of a kilometer in size. I'd be surprised if there's much more greater than 1/4 of a kilometer in size that have the potential to hit the Earth. So I think that in the long term, the problem is really as we find more and more of these asteroidal objects that are in short period orbits that can impact the Earth. Long period comets are going to be the problem because we don't know about them, right? They haven't been found yet. And those are the types of objects that can come very close to the Earth. I mean, we saw how close Hyakutake came in 96, how close Araki-Alcott came in 1983, and it's possible that something like that It could be a factor.
Thanks, Dan.
Thank you. Thank you, Imelda. Thank you, Edwin, and thank you, David, for that reaction. Before I proceed to the Q&A box questions, I would just like to mention something I remember about the book of Imelda and Edwin. It's entitled Second Coming, about Halley's Comet. And I remember it being relegated to the religious book section in the bookstores here in the Philippines because of the title, The Second Coming. Anyway, these are some of the questions in the Q&A box. Let me start with the first question. And I remember that the outburst you described about comet homes, because it was a very popular imaging target even here in the Philippines for astro imagers. And the question is, what is the cause of the outburst of comet homes?
No, I don't think we
From
know for
Robert
sure.
King. Yeah, Robert King. Yeah.
I don't think that we know for sure.
Okay.
It could be that it was impacted by something, a small meteoroid that hit it, or that it had some kind of vent on the surface nucleus that suddenly opened up and exploded material outward. But I don't think that we can know for sure.
Thank you. And thank you for that answer. And the second question is from Kay Lee. I'm not sure if this is the real name. And the question is, do we have a record of every undesignated comet? Citizen scientists have discovered hundreds of sun-grazing comets in SOHO and other solar observatory data, but they haven't been designated by the MPC because of their short arcs. What can be done to give these people more credit regarding the sun-grazing comets in SOHO and other solar observatory data?
Yeah, that has been a problem. So Brian Marsden basically did all the orbit computing, or most of it, of sun-grazing SOHO comets prior to his death in 2010, and there hasn't been anyone to pick up that slack. There's a lack of funding and a lack of interest at the MPC and in NASA for that. There have been proposals that have been put into NASA specifically for that reason, and the proposals have been turned down time and again. I've been a part of one or two of those proposals, and NASA's just turned down the funding for that. So I guess that NASA doesn't see an urgency to them, because these comets are, for the most part, they're dead. They go into the sun and they don't come out again on the other side, so they're not seen as that interesting. And so we're left with the statistics that we have prior to up through 2010, when Brian Marsden was doing them, and including them in his comet catalog, which he would put out every 3 or 4 years or so. There are a couple of online forums for this kind of thing. There's a sun-grazing comet group on Facebook, which is active. There are places where people can get credit for what they're doing online, but it's true that the Minor Planet Center has kind of dropped the ball on this particular part of comets.
Thank you, Dan. Now, I would like to read the next question from one of our watchers here in the Philippines, Mr. Val Thomas Abapo. And his message is, thank you, Daniel. Very insightful talk. I remember Comet Hyakutake as a small boy, observing and even sleeping at our terrace watching the beautiful long tail of Comet Hyakutake, if I remember correctly. It brought back wonderful memories. Thank you. My question is there a software similar to plate solving softwares that can take pictures of the sky and then calculate and show if these are out of place objects or suspected comets? Thank you. So is there a software that you can use when you're taking pictures that can tell you whether, yeah.
As far as I know, there's not easily accessible software. I have heard that the Catalina Sky Survey, which is part of the University of Arizona, is planning to make its software, it's basically, it's glorified blinking software, available for free to the general public. It's taxpayer funded. And I believe that at some point in the near future, it's going to be made available, where you put in multiple images and the software looks for moving objects. And in the case of at least some of these surveys, there is software that's supposed to look for extended objects, meaning, you know, diffuse, non-asteroidal, and flag it so that then an actual person can go and look and see if it really might be a comet or not. But as far as there being something you can just go and buy, I'm not aware of it. It doesn't mean that there isn't anything, but I'm just not aware of it right now.
Thank you, Daniel. This is a follow-up question from Kaylee. Hello, I'm a current high school student. I'm very interested in minor planets and comets. What do you recommend for people like me to make valuable contributions to comet astronomy? And he said, low budget options, please. So this is a high school student.
Yeah. Well, if you have a small telescope or binoculars, you can go out and make visual observations of the brightness and the size of the objects, and we take those observations and archive them. If you are able to take images, if you're a little more sophisticated, you can do astrometry, which can help. Astrometry is the measurement of positions as a function of time, and with those go to the Minor Planet Center, and they are used to compute orbits or refine orbits of comets. And there are also many telescopes now that are remotely used telescopes, most of which cost money, but not all of which cost money. If you find the right people, a lot of them, you can rent telescopes and you can observe comets, and many amateur astronomers do this every clear night. There are telescopes in the Southwest US, in Australia, in South Africa, in Spain, a lot of different countries, Chile, where you can rent time on telescopes and obtain images, and then you can do what you want with the images. And a lot of people measure comet positions with that, especially of new candidates. So one of the things, so the Minor Planet Center has something called the PCCP webpage, which is the Possible Comet Confirmation page. And on that page, the Minor Planet Center places objects that they think might be cometary, and so that people can go and observe them. And a lot of amateur astronomers go and observe those comets on a regular basis, and they report their observations to the Minor Planet Center, and it helps us to determine if they're comets or not, right? So, so anyway, back to the original question is that for a fee, you can rent a telescope, but there are some observatories, if you look around, and that will let you observe for free. And actually, the Smithsonian has one or two telescopes that does that. Smithsonian Observatory has some free telescopes that you can use to download images. You just tell it what part of the sky to look at, and it'll automatically do that, and then dump images into a file for you to access.
Thank you. Thank you, Daniel. And I guess you also answered this next question with that response. The question is from Raymond Ang. For amateurs, discovering comets might be out of reach because of automated surveys. Would outburst detection be a worthwhile activity for amateurs instead of comet hunting?
Yeah. I mean, there are many astronomers in the field of cometary science that are interested in outbursting comets. Some comets outburst frequently. There's a comet known as Schwarzmann-Bachmann, it's 29P, that orbits out beyond the orbit of Jupiter in an unusual orbit, and it has a frequent outbursts. It's a relatively circular orbit, which is unusual for a short period comet. but it has regular outbursts, and some of them are quite interesting. So yeah, there are things like that that can be done, and that kind of data is archived and of use to professional astronomers. So we encourage anything like that that amateurs might want to do.
Thank you. This one is from Daniel Fisher. What's your range of expectations for Comet C/2023 A3 Chuchin-Han Atlas next year?
Yeah.
What is your gut feeling of how it will perform?
Hi, Daniel Fisher. My feeling, we were talking about this earlier, but my feeling about it, this was before we went live, that I think that my hunch is that it might get up to about third magnitude, total visual magnitude, but it will be lost in the solar glare. So the head of the comet's going to be really, really hard to see, unless there is a huge enhancement of dust, which causes a forward scattering brightness increase. I think Joe Marcus had a look at that, and he didn't think it was going to be that big of an enhancement. So I don't see it getting brighter than second or third magnitude unless something weird happens, like with Comet West in 1976. Comet West split into four big chunks, and that caused it to be much brighter, apparently, than it would have been had it not split. So, you know, things can happen like that, but the problem is that near perihelion, near when it would be its brightest in October of 2024, this comet is going to be so close to the sun in terms of solar glare that our best hope, I think, is going to be if it's a really dusty comet, it may have a tail that's very impressive, and the tail may be visible outside of the solar glare if it's a long tail, like McNaught's comet in 2007. If it's something that's a possibility. But it's going to be, I don't think that the head of the comet is not going to be in the minus magnitudes unless something strange happens. So I would not get my hopes up too high on this, just because for about a month and a half around perihelion, the comet is it's around 10 or 5, 10, 15 degrees from the sun. It stays really close to the sun.
Thank you, Dan. So we have another question here from another famous friend, Joe Rayo. Does Dan have any clue as to why the mainstream media made such a big deal about C/2023 E3 CTF, the so-called green comet? From Joe.
Yeah, and the answer is I don't know. The thing is that it got out, the green comet thing got out there, the Neanderthal comet thing got out there. I did a video on this, which if you haven't seen, check it out on our YouTube channel. Specifically on, it's a short video, like a 2 or 3 minute video on the Neanderthal comet, trying to dispel some of the crazy things that the press was putting out. The press is always looking for a hook. You know, they're trying to sell copy, and I just think they went and ran with it. And you know, as I point out in the YouTube video, there are lots of green comets. You know, carbon creates a green signature, and basically any comet that's got any amount of carbon in it that's brighter than about 10th or 11th or 12th magnitude shows a green coma. And like when this comet was observed and they were making a big deal about it being a rare green coma, on our Facebook page, we had photographs being posted of 3 or 4 other comets that had a green coma that were fainter. So yeah, I don't understand the press, no, on this.
I think it's now how they sell stories nowadays.
Yeah.
Anything that will sell, yeah. So I have some more questions.
Which means the comet next year, by the way, the Sushin-Chan Atlas 2023 A3. I have a feeling that the press is going to go absolutely crazy with that comet next year.
Yeah, it might even outshine the Great American Solar Eclipse.
Yeah.
So here are some more questions, a few more questions. I think you partly answered this already with your lecture regarding the perturbation by gravitational perturbation. But the question is, why are comets, especially those that are making their first visit to the inner solar system, so hard to predict in terms of their maximum? It's about brightness. to predict in terms of their maximum visual brightness. So why is it hard to predict their brightness, especially those that are making their first visit to the inner solar system?
My answer to that is simple. They're not hard to predict.
Oh.
My answer is that people get careless in how they talk about or how they project comets brightening. And I did a study about 25 years ago now. It was at the time of Hale-Bopp, looking at bright comets. And I focused on comets like Kohoutek. Kohoutek's comet, which was discovered in 1973 F, and it came to perihelion in January of 74. That is talked about in the press and even among a lot of astronomers like it was a dud, and it was not a dud at all. In fact, what I showed in my study, in fact, if you saw my list of the brightest comets, Comet Kohoutek was, it's in the top 10 of the brightest comets of the last century. Got up to 0th magnitude. It was a nice comet. It was my first comet. So I have kind of a special place in my heart for Comet Kohoutek. What happened was that people were using a steeper increase. So in astronomical, in cometary terms, they had it increasing as 10 log R, in which, or even faster than that, even up to 15 log R, where R is the heliocentric distance of the comet from the sun in astronomical units. And what I found in my study 25 years ago is that most long period comets, including comets that are new from the Oort cloud, arise at more like a 7.5 to 8 log R. And you can represent Comet Kohoutek really well through its almost an entire light curve as around 8 log R. And that was the problem, is that, and my mentor, Brian Marsden, kind of had egg on his face after that, because he came out and was using something between 10 and 15 log R, which had it brightening a lot more in the prediction. And he learned a lesson from that. And in fact, I came under his mentorship after Comet Kohoutek, some years after that. And I heard all the stories from Brian about that. And he became very conservative after that, and he liked my going for the 8 log R, 7.5 log R, which in general, when we announce new comets and we put ephemerides out, and I did this for Comet 2023 A3, Sushinshan Atlas, which is the one that we're talking about that might be bright in October of 2024. I used 8 log R to get a peak brightness around maybe 3rd or 4th magnitude at perihelion. So that's the issue. And I think, so there are 2 answers to the question. One is use 8 log R instead of 10 log R or 12 log R, and you'll be a lot safer and you'll know more. It's more typical of what these comets do. And the second thing is that there are comets that fizzle out when they come close to the sun. They break apart, their nuclei fall apart. A lot of comets are not very well held together. And John Bortle showed decades ago that just in doing an analysis of different comets, that comets that are fainter than a certain absolute magnitude, if they come too close to the sun, they break up. They have a tendency to break up. So that's the other side of the coin. You either go with 8 log R, or and there. So the two things you have to look at. One is if a comet breaks up. If it falls apart, it's just going to disappear. Or if you have a comet west that was a big comet and it broke up into 4 big chunks and held together, all that extra material caused a brightness increase, right? So there are different ways. And Fred Whipple, I think, was the one who said, if you have to bet on a horse, not a comet. So, but we do the best that we can. And the best that we try to do is to be conservative and not to go overboard in terms of saying a comet might be bright. The point of today is, I think if you're really, really conservative, and then if the comet turns out to be really bright, in this day and age, communication is so instantaneous with the internet, right? That you can tell people, hey, it's 5 magnitudes brighter than we expected. Go out and look at it. You know, you don't have to project it being bright ahead of time. Project it being fainter, And then if it gets brighter, hey, everybody's happy. And you can tell people, go out and look now, it's there.
Great. Thank you, Dan. We are old enough to remember the famous comet Caltech. Thank you. Here's another question. Is it exclusively a feature of bright comets to be green? Or are very faint, greater than 20th magnitude comets also green, but just too faint for us to tell?
No, as I explained earlier, comets have to get closer to the sun to show it, but they're very common. It's very common to show the green color. But comets are not so gassy until they get into around 2.5, 3 to 3.5 AU is when sublimation really comes on, where you have water ice. Sometimes you have carbon monoxide a little further out, but you have to have a certain number of photons, yes, in order to show that green signature. And it usually happens when the comets are inside 2 AU from the sun, not further out. And the other point about the green comet business, like even with the ZTF comet in January and February this year, the point is that you could not see that with the naked eye. Okay, there aren't enough photons for the naked eye to pick up on that. So the color vision in the human eye needs a lot more light in order to do that. So all the green color was coming out of long exposure photographs, even some short exposure photographs. When I was picking up a green coma in 10-second exposures with a small camera. But the human eye needs more. You know, the human eye is a fraction of a second in terms of the exposure. So 10 seconds with a camera is a lot longer than what the human eye can do.
Thank you. Thank you, Dan, for the clarification. Now, this is another question regarding you mentioned something about comets disintegrating. And the question is, has the parent comet for the Kreutz-Sungrazer comets been identified? Have they determined when the parent comet disintegrated?
No, I think that we don't know all that much about them. The two people that did all the work on that were Brian Marsden and Zdenek Sekanina. If you watch our YouTube video on Sekanina, we have a couple questions with him on this particular topic. So I encourage people to look at our YouTube video and see what Dr. Sekanina has to say about it. And it basically, he thinks that we're overdue. We should be getting another bright component, bright sun-grazing component in the near future, sometime this century for sure, if not in the next decade or two. So we can only hope.
Thank you. I think we have a question from one of our panelists, Mr. Eric, Africa.
Oh, yes. Wonderful lecture, Dr. Green. I was curious. When in one of your slides, you were showing the chemical composition of Comet Halley, and that sparked a memory of the original Cosmos by Carl Sagan, because in the 1910 apparition of Halley's comet, they discovered, I believe, cyanide in the tail of the comet, so that triggered a scare. I remember people selling, or at least Carl Sagan talking about people selling comet pills or whatever to protect against the cyanide, since Earth was going to pass through the tail of Halley's comet. But I noticed in the composition, the composition of the comet from 1986 that there was no mention of cyanide. So I'm just curious, was the 1910 finding flawed, or
no, they're talking about C3. There was C3 detected. That's detected all the time in bright comets.
Okay.
Yeah, so it was just, it was realized for the first time a century ago when Halley's comet came by then. And I don't think that Halley's was necessarily the first comet that it was seen in. I think it was seen in other comets. The point was that we went through the tail of Halley's comet in 1910. And so people were worried that you know, that there might, that the Earth's atmosphere might be poisoned. But scientists at the time, astronomers at the time, pointed out in 1910 that the particles were so few and far between that there was no way it was going to do anything to the Earth or harm life on Earth.
Okay, thank you. Your lecture also sparked a memory of, well, this is for the last few months. I remember seeing on some forums about news about this really big comet that's making an approach. I don't remember its designation or anything, but I mean, this is a really massive comet, like almost minor planet size, but not to worry, it's perihelion, place it beyond the orbit of Saturn. So it's going to be really far away, but it's one of the largest cometary objects currently discovered.
Yeah, it's very interesting. There have been some estimates that it's over 100 kilometers in size, the nucleus, which is very interesting. But its perihelion distance is very far out, so it's not going to be. It would be really spectacular if it came in, you know, close to the sun. It'd be very spectacular near perihelion, but it's not going to come that close. But it's a very interesting, strange comet, and we keep finding strange comets. So we've had two objects that are interstellar that came just a couple of years apart. One which showed a cometary nature, and one just showed an asteroidal nature. And we always wonder. I wish that Brian Marsden had lived to see these things, because Brian and I we used to talk all the time about why aren't there any interstellar comets? And why haven't we seen one yet? And just a few years after Brian died, we had one object. The first one was Oumuamua, was an asteroidal type object, and that's caused a little bit of controversy, but because there are supposedly some non-gravitational forces with it. But some astronomers, like Dr. Sekanina, think they can be totally explained. But Avi Loeb at Harvard thinks that maybe it's an alien spaceship or something, and it was turning on its rockets as it went around the sun. But I don't think that most scientists follow that reasoning. And then the second one was a comet discovered by Borisov, an amateur astronomer, and but it too was clearly interstellar, coming from beyond the solar system. And the question is, how many of these objects are we going to see in the near future? Are we going to see any? Is it going to be 50 or 100 years before we see another one? We just don't know the answer to that yet. So, but it's very interesting. And we figured that there should be interstellar comets passing through the solar system on a regular basis. They must be out there. Comets must orbit other stars as well. It's not something unique to the solar system. And we certainly eject a lot of comets. We see a lot of comets that Jupiter ejects from the solar system. So they're going out there until they pass by another star, right?
Thank you.
Daniel. Yeah. Okay, Eric.
Thank you.
Thank you. Here's a follow-up question from Daniel Fisher. When Lovejoy self-destructed in 2011, we got a fantastic dust tail. When ISON did the same 2 years later, we didn't. Why the difference? And could we have known in advance regarding dust tails with comets?
I don't know the answer to that off the top of my head. I'm sorry. I would ask Dr. Sekanina that, and in fact, I will do that for you, Daniel Fisher, and I will get back to you with an answer from him.
Thank you. This question might be from our amateur astronomers who would like to emulate David Levy, one of the most prolific modern comet discoverers we have. And the question is, what do you think is the future of comet discoveries by amateur comet hunters now that large professional sky surveys are operating every clear night? So do we still have a chance of an amateur discovering a comet nowadays?
Oh yeah, they still are finding them, but they're few and far between. Yeah, the thing is that comets do sometimes come in from the direction of the sun. The surveys don't look all that close to the sun. So amateurs are going to have more success with CCD cameras looking at small solar elongations, so, right after sunset, right before sunrise, close to the horizon. Those are going to be the best chances. And I'm not sure about up near the poles. I presume the surveys are getting up near the poles now pretty regularly. Although I'm not totally sure about that, but I'm guessing that they do. I'd have to look. The MPC has graphs showing that the major surveys contribute to. They show what parts of the sky they're surveying every month, so you can see that. But we do get amateur discoveries from time to time. It still happens, and we get. I think it's probably on the order. I'd have to look, but it's on the order of 1 or 2 a year. Let me just take a quick look here. Oh yeah, Jost Jan found one from Germany. That was 2023 C1. He's an amateur astronomer. Go back before that. Well, I'm not finding quickly a lot more. The Attard Maury one. So Attard and Alan Maury, they found a bunch of comets, and they're technically amateur astronomers working out of Chile, I believe. They've found several comets in the last few years. Pretty sure they count as amateur, even though Alan Maury worked at Palomar for a while, back in the 80s or 90s. So as I said, they're on the order of 1 or 2 a year are being found via CCD, but visually, no, we're not getting the visual discoveries anymore.
In connection with that, there's a recent comment here from Sam Dean. Dan, they are doing pretty bad at the poles. TES tests managed to discover 5 different new comets at the South Pole, all of which were brighter than magnitude 20. And one that even reached magnitude 18. An amateur could have found any of those. Oh.
Yeah. Okay.
Yeah. And
hello,
Dan,
Sam.
So if any of our amateurs are lucky enough to win the lotto and discover a new comet, how do they report it exactly? What is the procedure?
For amateurs to report discoveries?
Yeah.
Well, they have to report accurate astrometry and information regarding the appearance to the Minor Planet Center, and we encourage them also to send it to the Central Bureau. Basically, what will happen is that they'll be put on the MPC's PCCP webpage, the Possible Comet Confirmation page, with ephemerides, and observations will be posted there that people can look at, and that's basically the way that you do it properly. But you need to send proper documentation about what you did, and who you are and where you are, and your telescope you used, and all that information if you want to get naming credit. So comets are named for their discoverers. And unlike minor planets, which are named by their discoverers and cannot be named for themselves. So
you have to go to the Minor Planet webpage and report there.
To officially report it, but the Minor Planet Center does not name comets. The IAU does that, and that's part of my working group that we work with. So when the Minor Planet Center decides that a comet is ready to announce, they inform us in the working group and ask us to give a name. And so we are generally in touch with, I'm generally in touch with the discoverers to find out, the basics of what's going on, and sometimes there's a little bit of controversy or question as to how a comet should be named. So sometimes we have to have a lot of back and forth with the discoverers to make sure that we get the name right. We have a multi-page set of guidelines that we wrote about 20 years ago, IAU guidelines for naming comets. And so we try to follow those guidelines. They were set up to be as fair as possible. We keep it so that we try to only have 1 or 2 names on a comet. 3 names is very rare, but that's the maximum that's allowed. And basically, if it's from a big survey, it either has to be one discoverer that finds it and reports it, and in order to get that person's name on it. Otherwise, it becomes a survey name. If there are 2 or more people involved, it's usually a survey name. So and some surveys like Pan-STARRS and Linear do not allow personal names. So even though they discover, Pan-STARRS and Linear has discovered the most comets in the last 20 years by far, none of them are named for people. They're just named Pan-STARRS or Linear. And the way that you distinguish them is by the year and letter, month letter designation. So that's why we tell people, don't just call comets ZTF or Pan-STARRS, because there are a lot of comets with those names. You know, you have to always give the designation so that we know which one you're talking about.
Thank you, Daniel. Thank you for your patience for answering the questions, but I have 1 or 2 more questions here before we stop the Q&A. So another question, I think these are 2 related questions regarding the definitions that you mentioned before. Mercury has been imaged in the wavelength of sodium where it has a tail behind it. Would Mercury be considered a cometary or dual status? And another related, the question is, 3200 Phaethon behaves like a comet in a way that it leaves debris on its path that becomes the Geminids. It's only missing tails. Does it make it anywhere the comet category? So the Mercury and the 200 Phaethon.
Yeah. Well, Phaethon is thought to be a defunct comet. Mercury is a major planet. So major planets do have atmospheres. The Earth actually has sort of a tail behind it too. So no, the comets are small bodies, not large bodies. But you know, where you have more of a problem is distinguishing comets from minor planets, because the boundary between what is a comet and what is a minor planet, when you get really faint, becomes harder and harder. So these new the surveys now, like Pan-STARRS and Atlas, and other comets, the LSST is going to come online soon, and they're going to be finding comets that are very faint and really very inactive if they're far from the sun. So they're going to be finding, the LSST is going to be finding a lot more objects that are not showing cometary activity, but are still comets. So basically, they're going to get minor planet designations, and that'll end up being comet designations. And what may happen in the future, 10 years from now or whatever, is that we'll have more comets with minor planet designations than comets with comet designations. So,
thank you. Yeah, thank you for that, Dr. Green. So I think this is the last question, and maybe it's someone who watched the movie Don't Look Up. What can humanity do if a large comet is found to be on direct collision course with Earth?
Probably not a whole lot. I don't know. It depends on what the defense departments are talking about, trying to send up some kind of a craft to nudge an object like that away from the Earth. But I don't know that I have enough faith in them to do it properly. So it's hard because comets have non-gravitational forces, right? Minor planets do not. So comets, because they have this jetting action, it actually causes them to move in a non-gravitational way, right? It's not purely gravitational. So that can be very hard to predict, and it makes it a lot more difficult.
Thank you, Dan. Before we end, there's a last question here. What is your favorite comet?
Oh, that's a tough one. Well, you know, when we started our YouTube channel last year, the three of us that started it, Charles Morris, Carl Hergenrother, and myself, we decided, it was actually, I think it was Carl's idea or maybe Charles's idea, to put out a video with our one comet that was very significant in our life. And the comet that I chose was IRAS-Araki-Alcock, because I was a young scientist then, just out of college, and it was really an exciting time for me. And so I encourage you to go look at my video on our YouTube channel of IRAS-Araki-Alcock. So, but in terms of comets, just in terms of their appearance in the sky, I would have to say Hyakutaki's comet in 1996 is probably, it's hard to outdo that comet, because I saw it from a dark sky and the tail stretched about 70 degrees across the sky. It was just amazing.
On that note, thank you so much again, Dan, for your time and patience. And allow me to present our small token of appreciation for your talk and for your time. So please allow me to present the ALP Certificate of Appreciation for your talk. And I would like to read it for you. The certificate from the Astronomical League of the Philippines is presented to Daniel W.E. Green for his invaluable insights, experiences, and expertise shared with the participants of the online talk entitled A Brief Tutorial on Comets, held as part of the ALP Astronomy Expert Speaker Series of 2023, given this 13th day of April, signed by Mr. James Kevin T., President, and yours truly, Jose Francisco Aguilar, Vice President. Thank you so much, Daniel. And maybe we can ask for a group picture. James, can you take a group picture with us? It's been a long day but a very enjoyable one. Thank you again.
Thank you. It was enjoyable for me as well.
James, you're muted. James, you're muted.
Sorry, ready? 1, 2.
Hold on.
Oh,
James, it's David.
Oh. Hey, where's David?
Did he sign up?
Oh, it's not yet. It's not here. Yeah, he signed out already, I think.
Okay.
But we have another picture with him before.
Okay.
Yeah, I have a picture. Okay, ready? 1, 2, 3. Okay, one more. 1, 2.
James, you're.
Yeah, James, you're
Hey.
on your side.
Okay.
Yeah.
Ready? 1, 2, 3. Okay, got it.
Thank you.
Thank you.
Thank you, Dan.
Thanks, Dan.
Thank you so much.
Thank you, Dan. Thank you, Dan, for
Thanks, Dan.
accepting our invitation. Thank you.
You're quite welcome.
Thank you very much.
So before we conclude today's webinar, I would like to thank all our attendees for joining us. We'll be sending your certificate of attendance for today's webinar by email to all registrants who were able to join us today. And we are grateful to all our webinar speakers who very generously gave their precious time to share their knowledge and expertise to the world astronomical community. We can never thank you enough. All our past webinars have all been recorded, and the videos of all the ALP Astronomy Expert Speaker Series talks can be viewed at your leisure at our official ALP YouTube channel as shown here. So after watching the YouTube videos, please don't forget to subscribe to our YouTube ALP channel as well. Thank you. And the next online talk for our ALP Astronomy Expert Speaker Series for 2023 will be on May 30, Saturday, 8:30 p.m. Philippine Standard Time, or 8:30 a.m. Eastern Daylight Time by none other than Dr. Deborah M.L. Green, the current president of the International Astronomical Union. Dr. Elme Green will discuss a glimpse of galaxies at the dawn of the universe And as you can see here, Dr. Elmer Green also wrote the book, Galaxies and Galactic Structure. So we will be posting the registration link for this free webinar at the webpage of the Astronomical League of the Philippines. This is a free webinar, just like all our past webinars. So please register once we post the link at our ALP webpage and Facebook page. Thank you, everyone. Thank you very much, everyone, for attending, and clear skies always. Bye-bye.
Okay. Bye-bye.
Thank you.
Everyone. Thank you.
Bye-bye.
Bye.
Bye.